So this presentation is about gravitational force. Supposedly, according to myth and legend, Sir Isaac Newton was sleeping under an apple tree when he was bombarded by a falling apple that landed on his head, and then he magically thought up gravity. However, it's much more likely that he just simply watched an apple fall from the tree. Now this got Newton thinking, why do things fall? And then he thought up this idea called an orbital cannon. Picture yourself throwing a baseball or some other sort of ball. Now eventually the ball is going to hit the ground, and is not going to hit the ground straight down unless the ball is thrown straight up. It's always poised to come down in almost a gentle curve of sorts. And no one starts to wonder, what if he could create this scientific cannon that could shoot a cannonball fast enough that once the ball started falling, it would just continuously fall around the earth. He decided that he would need to kind of get it to get this right speed, and that if it kept falling around the earth, there must be some sort of force pulling it down. This force became the idea of gravity. After much research in mathematics, he determined the law of universal gravitation, which states that any two bodies in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Which means that while the earth pulls you down when you jump up, you also pull the earth up. But it's important to remember that in closed systems, the net force is equal to the mass times the acceleration. And because the earth is so freakishly huge, when the acceleration is incredibly small, so while the earth pulls you down incredibly, you don't pull the earth that much in the end. So the equation is that G, which is the universal gravitational constant, and is equal to 6.67 times 10 to the negative 11th times the mass of the first object times the mass of the second object divided by the radius squared. Now the radius is not the distance between the outer edges of the objects, but the distance between the center of the spheres. So in this picture you can see a minor demonstration. You can see that all of the variables are the same in the equation F equals G times M divided by R squared. So that means that the force between the two objects is the same. The only thing that would differ is if you increase the mass of one object, then the force increases between both objects. If you increase the mass of the other object, then this force again increases between both objects. And if you increase the distance between the objects, then the force decreases. Now, it's important to note that switching the position of the spheres does not in any way affect the mass, no, the force. So let's say you take the red sphere, you move it to the right, the green sphere, you move to the left. No difference has been made on the force. You take the red sphere and you move it the same distance from the green sphere as it originally was, but on the right instead of the left. The force is still equal. So, in recapitulation, F is equal to G, which is the universal gravitational constant, times M, times the mass of the second object, divided by the radius squared, which is the distance between the centers of both objects. Changing the position does nothing to the force, only changing the distance or the masses between. And that is the basic of the concepts.